friends, now we are going to learn mathematical analysis of non-recursive algorithm. As we are aware, we are writing the programs using recursive or non-recursive algorithms. In non-recursive algorithms, generally we will use conditional loop, for loop, while loop, do while loop, and so on, right? While recursive algorithms, we are going to use if-else statements. We are not using the loop generally. And second thing is, recursive function is called function calling itself. Even complex problems, you can solve it in lesser amount of space by using the recursive functions. So here we are going to find time complexity for non-recursive algorithms, a time complexity for recursive algorithms. So you have certain general plan to use in order to find out the complexity of given examples. What is general plan for analyzing efficiency of non-recursive algorithms is, first of all, we are going to find their input size and parameters are there with the functions. Then we are going to identify, very important, is called basic operations. As we are aware, each and every algorithms got some basic operations. Our instructions is repeated more number of times is called it as a basic operations. Say, as we all aware, bubble sort algorithms to sort the elements. Their basic operation is comparisons. We are going to compare the elements. That is called basic operations. So then, how many number of comparisons you have done? How many number of comparisons you have done using if statements? That is going to be basic operations for bubble sort. When you call it as a matrix multiplications, example 2, matrix multiplications, and we have seen that in matrix multiplications we are writing one instructions called C of ij is equal to C of ij plus A of ik into B of kj. So that particular multiplicative instructions we are going to use many number of times, right? That is called basic operations. So depends on the problem scenarios, our basic operations change. So we are going to identify which one could be the basic operation for given problem scenario. Once it has been done, then based on the input size, we are going to discuss, right, what will be the best case scenarios, worst case scenarios, and average case scenarios. As we studied earlier, right, and I said basic operations are executed lesser amount of time, lesser number of times than it is called best case. A basic operations is repeated more number of times is called worst case, and it is comparatively, it is between best case and worst case scenario is called average case. Then after that we are going to set up the sum expression. And what is sum expression, friend? As we have using in mathematics summation symbol. So we are going to set up the summation of C of n, that is time complexity. Number of times, basically it is, as you are writing the for loop, I is equal to 0 to I less than n. So I is equal to 0 to n is initial values and last values we are going to mention there. So set up the sum expression is very important, right? Then once sum expression is ready, we are going to use mathematical formula or process to solve the problem. And after solving it, we will get the final time complexity, and that we are going to summarize it or simplify it in nearby the standard form of order of growth. As we have studied order of growth, we have a log n base 2, n square, n cube, 2 power n, n factorial. These all are the standard time complexity order of growth. So we are going to find that values. And based on this, we have many examples. Out of that, we have taken some examples, finding the largest element in the given arrays, elements, uniqueness problems, matrix multiplications. So out of this, we will see that some examples, how you are going to compute the time complexity. Let us see. Example 1. We are going to find out factorial. Okay. find factorial of the given number using non-recursive algorithms. So in that case, we are writing the simple code, right? We can write it fact int n, and since you are writing non-recursive algorithms, you have to use the any conditional loop, for loop, while loop kind of, right? And we are going to define, say we have a int I, we have a, say, factorial is a variable, right? And we are going to use for loop for I is equal to, as we all aware, factorial of 1 is 1, right? Factorial of 0 is also 1. So we are going to write I is equal to 1, I less than equal to n, I plus plus, and inside we are going to write factorial is equal to factorial into I. So this statement will repeat again and again, right? Hence we must define, right, int I. So factorial initial values must be defined as a 1. Must be defined as a 1. Then you are going to perform this task again and again, and finally you are going to write return factorial to the main function, return factorial, right? Look, this is a very simple algorithms. As per the given general plan, we have discussed that first decide on the parameter and input size, right? So here parameter is, say, input size is n. Then we are focused on what is the basic operations, decide on the basic operations. Operation is repeated many number of times is called basic operations, and in this particular scenarios factorial is equal to factorial into I. That is repeating again and again until this condition is failed. So this is the basic operations, right? So based on this loop, this basic operation is going to repeat from 1 to n time. Now, what is the step 3? Step 3 is we are going to think of worst case, average case, best case scenarios, and fourth is, set up some expressions or summations, right, in order to find out proper complexity. So what is that? Let us see that. Set up some expression is like we are going to write summation symbol T of n is equal to, what is initial values of I is equal to 1, final values of I is n, and for basic operations you are going to write it 1. So this is summation, set of summation expressions for the time come setting. So we are writing I is equal to 1 to n. This one instruction is basic operation is repeated from 1 to n time. Now how are you going to simplify it? Fifth step is simplify this by using well-known formula or procedures. So how are you going to simplify this? We are going to simplify it like upper limit minus lower limit plus 1. So upper limit is n, minus lower limit is 1, and plus for whatever the values are there in the basic operations 1. So 1 and this minus 1 got cancelled, and finally we are getting n. So time complexity for factorial using non-recursive algorithm is, we can say that theta of n, right? And we can note this when you are solving this summation expression, we are going to write it upper limit minus lower limit plus 1 for basic operations. That we are going to use it for all the problem scenarios. So let us see Next problem. Say second is matrix multiplication. A moment I have written matrix multiplications, you will be knowing that what logic to be right to perform matrix multiplications. So I am writing here matrix multiplications, and here we have different matrix. As you are knowing, the matrix is order 2, right? Like two-dimensional array. So A and we have a B as a matrix. When you are going to solve this, right, we have to use nested for loop. How many for loop? 3 for loop. First we are going to write for number of row I is equal to 1, I less than equal to n, and I plus plus. If it is a square matrix, then number of row and number of columns are same. So we can write it for j is equal to 1, j less than equal to n, and j plus plus. Remember that if order of matrix are 3 by 3, 2 by 2, then number of row, number of columns are same. Otherwise, you can write it here row number and here column number and proceed. Then we are writing C of initial values as a 0, right? And thereafter again you are going to write for, right, k is equal to 1, k less than equal to n, and k plus plus. For what reason? Remember that matrix multiplication is possible when number of row is equal to number of column, and k is here intermediate row and column. So k will behave as a row as well as column. Inside we are going to write very interesting one line. C of ij is equal to C of ij plus. Now what is the first matrix? Is A. Second matrix is B. So we are going to write A of ik. Remember that what is k? K is intermediate row and column, multiply by B of kj. So these all you have already studied, right? Just I am trying to tell you that how you are going to compute that time complexity. So basically this is a basic operations as per our basic operations as per our general plan. Then input size, remember that here is number of row and number of columns. If it is been done, then you are going to write setup expression. Remember that setup expressions will be there for all for loop separately. And since it is nested for loop, then we have to write nested setup expressions. And which one are going to solve first? First we are going to solve last expressions, then jth expressions, then ith expressions. In that case, one thing is there, all the for loop is start from 1 to n, j is equal to 1 to n, and we have k is equal to 1 to n. So not a problem. We can write it now like time complexity of matrix multiplications, right? Or you can just write T mat of n. Time complexity of matrix multiplications is summation of first for loop start from I is equal to 1 to n. Then second for loop start from j is equal to n. Third for loop start from k is equal to 1 to n. And basic operations, as I mentioned that last statements, innermost loop we have a statement C of ij is equal to C of ij plus A of ik into B of kj. Then in previous example we have discussed upper limit minus lower limit plus 1. So here n minus 1 plus 1 we are going to simplify this. So outer loop will keep as it is. First we are going to solve inner loop. What is that? N minus 1 plus 1. Upper limit minus lower limit plus 1. 1 and 1 got cancelled. So in that case, we have I is equal to 1 to n, j is equal to 1 to n, and here we got n. Remember that this n is not depends on j value. J value is j is equal to 1, j is equal to 2, 3, 4, 5, n. So this n is not depends on j value, hence n we can take it outside. So now it looks like I is equal to 1 to n, j is equal to 1 to n, and if n we are taking out, it means what is left here? 1. N into 1 is n, 1. Again you simplify this with the same way. I is equal to 1, upper limit minus lower limit plus 1, n minus 1 plus 1, right? This 1 and 1 got cancelled. Again n is left. So again this n is not depends on I, value of I is equal to 1 to n. Hence n you can take it out. So now n into n becomes n square into summation of I is equal to 1 to n. What is left? If n is taken out, then here is left is 1, right? Now again apply the same upper limit minus lower limit plus 1. So it is n square into n minus 1 plus 1 got cancelled. So we are getting n, and overall value is n square into n is n cube. So we can conclude time complexity for matrix multiplication is n cube. Now we can compare. When we have used in non-recursive algorithm one for loop, we got time complexity n. When in the given algorithms we have used nested for loop 3 times, we got n cube. It means what? Each and every for loop is capable of giving 1 n if it is in nested form. Similarly, when you are going and dealing with bubble sort, remember that bubble sort we have a 2 for loop, hence n into n will give you n square. Selection sort we have a 2 for loop, n into n will give you n square. Insertion sort again n square. Uniqueness of the number, when you are going to check the duplications of the number, it is n square, right? And I discussed one more examples there, that finding the largest of elements. So finding the largest of elements, one for loop is enough to find the largest element, hence it is n. Matrix multiplications, just now we have saw n cube, and uniqueness of the problem we are going to discuss, complexity is n square. So I believe you understood how to compute this time complexity for the given non-recursive algorithms. Now let us say one more examples. Yeah, I was talking about addition of 2 matrix, right, or subtraction of 2 matrix. So in that case, when you are doing addition of 2 matrix, right, we have to use nested for loop. So let us see that. 1, just to write add matrix, and we are writing here int a and int b, and we can write here is for I is equal to 0, I less than n, I plus plus. When you are starting from 0 less than n, starting from 1 less than equal to n. For j is equal to 0, j less than n, j plus plus. Now we can write addition of 2 matrix. How you going to write it? Say C is resultant matrix, we can write C of ij is equal to A of ij plus B of ij. So this will give you addition of 2 matrix. If you are going for subtraction of 2 matrix, just use here subtraction symbol, minus symbol, it will give you that subtraction of two matrix. Right? Now, how are you going to find time complexity? Remember that first you are going to write T of n. We find that range of input, it is 0 to n. Remember that n is not included. So, we are writing here I is equal to 0 to I less than n. I less than n means what? Maximum will go n minus 1. Similarly, j is equal to 0. J less than n. It is not n. Lesser than n means maximum value is n minus 1. And this is basic operations. Basic operations. So, we are going to use 1. And we are going to solve this in order to find out time complexity for addition of two matrix. Right? So, how are you going to do? We can write T of n is equal to 0 to n minus 1, 0 to n minus 1, 1. Upper limit minus lower limit plus 1. Same things. So, we are getting I is equal to 0, n minus 1, upper limit n minus 1 minus 0 plus 1. Right? So, this 1 and 1 got cancelled. N is a constant. Take it outside. Then we got I is equal to 0, n minus 1, and here is constant values 1. So, can we do that? N into n minus 1 minus 0 plus 1, again 1 and 1 got cancelled, and final value is n square. So, we can say that time complexity for matrix additions or subtraction is n square. Yeah. So, in this part we have learned mathematical analysis for non-recursive algorithms, and we have discussed with 3 different problem scenarios. In one case we got time complexity of n, second we got time complexity of n square, and third case we got time complexity of n cube. Thank you.